This video reviews the different types of daylight analysis that are available in Sefaira. When you open the daylight visualization, you'll notice a number of daylight analysis options in the menu on the left side of the screen. The default is an annual simulation. This is generally the best option for early-stage design purposes. An annual simulation performs an hour-by-hour daylight analysis using the weather file from the location that you've entered in the plugin setup. As a result, the results are better representations of daylight throughout the year than other types of simulations. The metric for the annual simulation is daylight autonomy, essentially a measure of how often the space is sufficiently lit through daylight alone. Specifically, it shows the percentage of occupied hours that receive a minimum amount of illuminance. And that minimum is initially set to 300 lux. You can see it here in this menu. And you can adjust that threshold based on a different use type that you may have in your design. By the way, if you prefer to work in foot candles rather than lux, that option is available in the settings menu. In the top right of the plugin, click the gear icon and you can switch between lux and foot candles. As I said, the annual simulations are a great tool for understanding design early on, and specifically for understanding whether a space is generally well lit or for comparing different design options. The next type of simulation we'll look at is a date and time analysis. As this sounds like, it is an analysis at a specific day and time of the year. Date and time analysis can be useful for diving into best case or worst case conditions throughout the year. The third type of analysis is overlit and underlit. This analysis actually aggregates two different daylighting metrics to give you a composite picture of potential problem areas. Overlit is an annual sunlight exposure metric, which indicates areas that have more than 1,000 lux of direct light only for more than 250 occupied hours per year. And underlit areas are a daylight autonomy metric, where you have less than 300 lux for more than 50% of occupied hours. And the total SDA and ASE numbers are shown at the bottom of this visualization. You can see that this building is mostly underlit. You'll also notice as I hover over the floor that you'll be able to look at results on a room-by-room basis. If you click on any room, you can see the SDA and ASE figures for that room only. Note that because the hour thresholds add up to well under 100% for those two metrics, it is possible for a space to be considered both underlit and overlit. That means over the course of the year, it's not quite getting enough light overall, but it has more than those 250 hours of direct sunlight. The thresholds for these metrics are aligned with the LEED version 4 daylighting credits, and in fact, the green areas at the bottom of the screen indicate the point thresholds for different LEED points. So this analysis is good for doing early benchmarking toward those LEED credits. I should note that it can't be used for final compliance purposes. It's also good for just doing early identification of potential problem areas in your design. The fourth type of daylight analysis is daylight factor. Daylight factor is simply the ratio of exterior to interior illuminance under an overcast sky. It's not location specific, so the daylight factor of any building would be the same in Miami, Florida as it would be in Stockholm. Daylight factor has generally been superseded in recent years by annual metrics, which are more representative of actual daylight performance. But daylight factor is still the basis of code compliance in certain areas. Like the overlit and underlit analysis, you can get room-by-room results if you've defined rooms in your building. And you can also see the average daylight factor as well as the minimum point and the uniformity ratio, which is a measure of how uniform the daylight is across the floor plate. The final metric that we'll look at is direct sunlight analysis. And as you likely expect from the name, it is direct sunlight only. What this visual shows is the percentage of days that receive a minimum number of hours of direct sunlight every day over a given time span. So just on June 21st, in this case, the percentage of days that receive minimum 3 hours of direct sunlight. I can adjust that time frame, I can adjust the starting and ending point of the analysis, and I can adjust the minimum hours per day. This type of analysis is good for passive solar design. You can use it to try to maximize direct sunlight during a heating season and minimize direct sunlight during the cooling season. It can also be used for CEP 65 compliance in Australia. CEP 65 requires a minimum number of hours of direct sunlight in residential buildings. And it's also useful for studying direct sunlight in exterior spaces. You can tag the outside ground plane as a floor area and everything else as shading, and then the daylighting analysis will show up on the outside of your building. Similar to some of the other daylight options that we looked at, you can also look at these options on a room-by-room basis.